transformer, c'est ça. Et vu que tu l'as déjà créé,
so
là, la liste, elle est là.
so let's eject out of here.
Et
Now
du
we've
coup,
got
tu
our
vois,
things, that's good. So let's go back into here. So we had our
Et donc,
cut,
si on regarde en
another
final,
big
du coup,
step
ça,
over.
lourd, hein, la pièce, elle est déjà lourde, il n'y a pas de souci.
Picked our point.
Donc,
Picked
on
our point.
dit le disque. Et là, en fait, si tu fais,
Oh, update stock.
donc si tu fais tes opérations que tu fais sur ta première gauche au disque, l'idée c'est de faire un coup de disque à plat à ce niveau ici. Donc, en fait, pour orienter la tête, hein, jusqu'à présent, on faisait ici, là. En fait, ici, tu faisais sur une face. Hein. Ouais, tu faisais plus sur une face. Mais là, on doit rester vertical, on y est déjà.
No.
Donc on ne peut pas changer l'orientation.
Blood.
C'est la phase dessus et c'est pas ça qui va faire tourner.
Okay,
En
that
fait,
did work.
là, j'ai le droit, quand je suis dans cette cas-là, de faire tourner moi avec des valeurs ici. Donc ici, on a besoin de moins 90 pour mettre notre tête devant ça. Là, si tu fais ça, du coup,
That should matter.
tu fais ta programmation.
Is it maybe
maintenant,
not the
et
right
donc, en
height
fait,
point?
quand le A est vertical,
Redo
But there's
the
only one point.
là et seulement là, tu as le droit de changer la valeur du C puisque ça n'affecte pas la direction en fait.
Yeah,
La direction
crossing
est
point?
verticale. Si tu veux tourner le C, ça reste vertical.
What is it,
Le
parametric
moindre
pounds, additional
micro
source,
de degré que j'ai donc si je fais le C, ça génère une rotation. Et là, j'ai plus le droit.
So I think we do the blade, no. How do we set the blade?
We have I think there's blood coming out.
What?
It's
So,
set.
when we simulate, it turns in the right orientation, it goes down, but it drops down way too low, and then does bad things.
Same thing.
Look.
So that's not so bad. Okay.
And then blood.
And then blood.
Oh.
When I say, and then blood.
The horror.
Okay. So maybe we can have a look together.
Yep.
May I
Yes, you want to
maybe
sit here?
explain this?
We're manufacturing stuff.
Okay. So if I open this, what define where I work is the pink block, the step over,
Yep.
so that's fine, and the crossing point. So you did a good job. The only only thing
Teamwork.
you cannot forget it because I never say it. Where start the machining? It's at the beginning of the pink block. So the beginning of the pink block is here. So if it is in the stone, in the material, then you have a tool path here. So if you don't want to have this cut over there, you extend it outside, and then it's okay.
So it was searching for that bottom.
The beginning of the work, the job start at the bottom part of the pink box. Bottom in this case because we are in the vertical position. So in the Z direction, we can say
Okay.
for it, the Z. This is the Z direction. If I show you in panoramic bonds, if I move this, you see move in Z minimum. So the work, the machining start at the Z minimum. So if the Z minimum is out of the stone, the machine does nothing because
Okay.
it's out.
Yeah.
Why doesn't the
If I put it here, I will have a cut here. You see,
But isn't the cut at the crossing point? Like we told it to cut at the
the crossing point is here. This one is the crossing point.
But I don't think it didn't go into the stone.
Okay.
let me explain this after. So first of all, for this one, so just extend it a little away from the block, and then you have only one cut. So you did this cut,
Oh, okay.
fine, but maybe we could go a little deeper. Why it stopped there? Because if I let me switch off the machine, it switch off because
So it should have been the other crossing point.
yeah,
We debated that, but we.
you took the wrong one.
Right.
Okay, and one more thing, if I
So would we just make the crossing point up top higher or at the other side of that?
on the other side,
Interior, exterior.
Oh, yes, okay, okay.
and one more thing, you see the trajectory is not straight, so it's because if I go step by step, maybe I can remove part of the machine. So the change of trajectory, it's when we get out of the part, then the blade can plunge in the material because there's nothing to stop it.
Right, because it's
Okay.
just keep the blade away
Yeah.
2 mils or whatever.
Yeah. So that's why we have this trajectory like this. Okay.
Okay.
So what we should do? Crossing point has to be here and not here.
We would have seen that if we oriented this on, then look, I guess probably. So right there.
So if I apply this, is it better or not? Yes, it's better. Okay. But now, if I simulate this, too deep.
Because the flange is gonna hit?
Yeah. The flange, the motor, and everything hit. So if I do a verification of this one, Korean.
Blood everywhere.
Oh, nice pace. Okay, so how do I stop it?
Would, do we specify the flange somewhere?
No. In fact, we use it to generate it and to. It doesn't affect the trajectory. So how do I stop it?
Well, specify the depth.
This morning when we did the incline cut,
Yeah.
how did we stop it?
With the
lines.
box. Okay.
So this is 0 because 0 is here.
37 is good.
So how much is the blade? So anyway, let's try this. It's no big deal. So you see it stop over there.
It's 550 minus the flange.
Yeah, the flange
Yeah.
is 250, so half the flange.
Okay. You see we
So
can
that's-
do a little more.
Okay. Good. So we chose the exterior
Yes.
instead of interior,
Uh,
or opposite.
opposite.
Okay.
Extrude,
Exterior